My name's Brandon Shockley. This is a introduction to the Biofuels and Land Use Change group project. Between 2001 and 2012, the United States went from a consumption rate of 244 MBBL a year to 21,406 MBBL a year. MBBL stands for thousands of barrels. In 2013, that number jumped to 34,020 MBBL a year. Between 2000 and 2010, nearly 60% of the global land purchases in the last decade have been made solely for the production of biofuel. More than 60% of that land was purchased from developing countries by foreign investors. This has led to concerns of land use change, land rights and governance, and food security as well. Some of the stakeholders include farmers who are converting land to produce biofuel crops, increasing natural pollution in the process. The fossil fuel industry, transitioning from fossil fuels could lead to a rapid transfer of wealth out of their market and put thousands of jobs at risk. People in farming communities who are importing food now instead of eating it locally, which also leads to an increase in pollution and the possible loss of their land resources if the land is purchased by someone outside of their community. Some of the actions that led to these circumstances are a rapid increase in the world's population, affluence and technology, instability and scarcity concerns of the fossil fuel industry, emerging markets, making biomass farming more lucrative for farmers and their communities, and government requirements trying to curb the effects of greenhouse gases, including the introduction of bioethanol to the U.S.'s gasoline mixture. Some of the effects of these circumstances are increased natural pollution caused by overfarming and resupplying of soil, nutrients to the soil, a loss of natural habitat and biodiversity as land use change occurs, increased pollution as food and fuel are imported and exported, transitioning from older technology to newer technology, which is more adept at using fuels with higher ethanol blends, and a possibility of reliance on foreign land. Up next, we have Candace, who's going to be introducing the carbon cycle to us, as well as some of the drivers that impact the biofuels and land use change wicked problem.
Hello, my name is Candace Robatoy. I am with Group Green Day, and I will be talking a little bit about the biochemical cycles in relation to biofuels and land use change. The most affected biochemical cycle when related to biofuels and land use change is the carbon cycle. Biofuel production is considered to be more sustainable because, unlike fossil fuels, they are able to be replenished rapidly, meaning we're able to produce biofuels as quickly as they are consumed. Fossil fuels are a limited resource, and their extraction is causing negative impacts across the globe. For example, Peru is currently in the midst of a cleanup project for petroleum leaks in the Amazon. The Deep Horizon spill of 2010 is another example of the type of environmental disasters that extracting fossil fuels is causing. It can sometimes take several years for ecosystems to recover from these types of environmental catastrophes. However, biofuel production has negative impacts on the carbon cycle as well. The most prominent effects are in the form of CO2 emissions into the atmosphere. Not only does burning carbon fuels release CO2 into the atmosphere, but production and distribution also increases this effect as machinery and large distribution vehicles are a necessary part of the process. Current forms of biofuels, or first-generation biofuels as they're known, are primarily made from corn and sugarcane. In order to produce these first-generation biofuels, current produce and feed crop land has to be converted to grow biomass for biofuels. On a large scale, this process has the potential to cause other negative outcomes such as food shortages around the world. As the demand for biofuels increases, more land is needed, which leads to even more CO2 emissions from machinery needed to convert forest and marshlands into suitable farmland for biomass. This is where the issue of land use change comes into play. It is clear that while biofuels are considered more sustainable, we as a society still have a ways to go to make the process truly a socially sustainable and environmentally responsible option. Next, you will hear from Lisa Krewalt, regarding drivers and indicators of biofuels and land use change, as well as our group's vision for the future.
Hi, my name is Lisa Krewald, and I'll be reviewing our group's research of drivers, indicators, current scenario, and vision. There are 4 primary drivers of our wicked problem of biofuel and land use change. These are increased energy consumption, increased black carbon in the atmosphere, energy security, and the increase in biofuel. Each of these drivers has its own set of secondary drivers that you can see in our visual representation on the slide. The indicators that we would use to monitor the effects of biofuels and land use change are the destruction of forest areas in developing countries such as Brazil and Colombia, the prevalence of underweight or malnourished children under the age of 5, carbon dioxide emissions in the United States by the kiloton, United States exports of ethanol in the thousands of barrels, and the shares of corn and soybean oil produced in the United States that are used in the production of ethanol and biodiesel. The problem faced with biofuels and land use change is the opposite of the problem it was set out to solve. There is a shift in the carbon cycle causing an increase of carbon in the atmosphere. One of the current scenarios our group focused on was the implementation of biochar in current farming practices. Biochar is a charcoal made from plant materials that can be used in soils to allow for more water to be stored, and it also promotes carbon sequestration in soil that otherwise wouldn't have been able to store as much carbon, if any. This allows carbon to stay in the soil longer, reducing the overall amount of carbon that ends up in our atmosphere too quickly. However, the use of biochar as a solution isn't enough. Our group proposes a new vision that focuses on changing the use of fossil fuels and biofuels entirely. We would like to see all individual consumer vehicles transition to become all electric, while commercial and military vehicles switch to second and third tier biomass fuel. This vision will reduce the amount of fossil fuels used in the United States to zero, and it will also reduce the amount of biofuel and biodiesel overall. There are certainly hurdles to overcome, such as our current technology for electric vehicles being more efficient and affordable, but this is our ultimate goal: to reduce carbon emissions and to heal our lands that have been scarred for the production of fuel alternatives. Next, Ryan Newton will speak about our transition strategy and our conclusion.
Hi there. Thanks, guys. Team Green Day is of the ecological perspective. Thus, we believe that the best way to solve the wicked problem of biofuels and land use change is to completely revolutionize it. Our transition strategy is fairly straightforward. The elimination of fossil fuels is our goal, but our main progress indicator will be CO2 emissions. Our goal will be complete independence from fossil fuels by the year 2036, reducing carbon emissions to 10% of what it was this year, which was 5.5 million kilotons. Here are our strategies for transition. 1. Increase social awareness. Focus on influencing decision makers of the future. Science centers around the country present sustainable education to children and adults alike. Below you can see an exhibit called the Aquavator at Discovery Cube, Los Angeles that teaches kids about aquifers and groundwater stocks. Our target audience would be well reached by a respected leader or innovator. Recent examples of this include Leonardo DiCaprio speaking at the United Nations Climate Summit, Elon Musk presenting the Hyperloop in 2013, and Al Gore's film An Inconvenient Truth. We also need to have a central world government to facilitate communication between the governments and have cooperation and agreements to guide people to be more sustainable, and countries alike. The United Nations is our world government, and they have commissioned the International Intergovernmental Panel for Climate Change to have the sole purpose of stabilizing gas concentrations. Also, we need to develop and distribute alternative energies. First, next generation biofuels that have little to no carbon footprint are going to be necessary if we're going to reach a sustainable status. Wind, solar, and fusion also, we want to develop those. According to Stephen Cowley, a research physicist, this has already been done on a very small scale. It's not commercially viable yet to produce energy using fusion reaction, but it is in the future. Replacement transportation technologies such as electric cars, high-speed rail, hyperloop technologies also need to be developed. Also, we want to accelerate social change through taxes and subsidies. Using top-down method, this framework should start on the global level, not on the country level. Increase taxes on countries for carbon emissions and pay for externalities such as land use change. Subsidies like clean energy will implement clean energy strategies at the consumer and producer levels. Also, we want to employ habitat protection agreements on a global level. Barriers include financial costs of transitioning, technological advancements required such as fusion, and political cooperation needed to implement laws and policies. Cultural resistance is always going to be a barrier and obstacle. Most people will be resistant to change. That's why effective transition strategy is required. Conclusion: the answer to climate change lies in a combination of limiting our consumption, transitioning to cleaner energy, and protecting the environment. If we can learn to live sustainably on the earth rather than bankrupting our resources, humanity will have a much brighter future. On behalf of Brandon Shockley, Lisa Krewall, Candace Robitaille, and myself, Ryan Newton, we all encourage you to live more sustainably. Thank you.